Hello everyone. Today we're going to start a video on parametric precedent. It's been a while. I'm currently in school, so I don't have a lot of time anymore. I'm working and going to school at the same time, so I do not have a lot of time. So yeah, this will be a parametric precedent, like the videos I used to do. I found this one pretty interesting and pretty simple in some ways. So I wanted to show you guys how I would do it as well. So right off the bat, we can see that there's these patterns here. So there's a curve here and a curve here. So it looks like a sine curve. So we'll stick with the sine curve, but I'll also show you how to just use your own curve as well. So you don't have to exactly use a sine curve here. You can actually just use your own curve, but we will stick with a sine curve in this case as well. So yeah, as you can see, there's multiple pictures here. They have one with a window. So this was probably done manually, but we're just going to get the general principle of this. And then this was probably done manually as well. But yeah, so this is by this French architect, I think. So they use some structural stone. So this is pretty cool. But what we're interested in right now is the design. So we'll get right into that. They actually have some pretty good joints here too. Anyways, so let's get started. So I hope the audio is good. I have a new mic set up now, so I hope it works out as well. So let me just do this. Oops. So yeah, let's get started. So there's two ways we can do it. I'm going to show you the first way with just Grasshopper, and then the second way with control curves. So we're going to start with just Grasshopper. So what we're going to do is we're actually going to start with a construct point. If I can spell construct point. It's a little hard to type with this mic in front of me. I have to get used to it. But what we're going to do, we're going to go in top view for right now. And then we're going to do Z. Well, not Z. We're going to go in the X direction. So in this case, we're going to go in the X direction and move it a series of points. So we just type in series and plug it into X. I almost did Y. So right now, by default, it does 10 points by 1 unit each. So the step is 1, so 1 millimeter, and a count of 10. So there's 10 total. Should be 10. Yep, 10 total with the step of 1 and the start at 0. So we can work with that for right now. But probably need to add a range in here as well. So there's ways we could do it. We could just do move through here, or you can also plug it into here. But this is visually more intuitive, so I'm going to stick with that. So we're going to go with Y, move. So we have this range component, and we notice that there is a sine curve going on here, or a very consistent mathematical curve. In this case, I'm going to interpret it as a sine curve. So I'm going to use a graph mapper. You can also technically use sine, but I actually like using the graph mapper. So technically you could use this. I think you can, at least. I haven't tried it. So note, I haven't even made this script yet. So this is just me kind of spitballing and wondering, I don't know what this is. Me just spitballing and kind of figuring out what works, and based on the images and based on my experience. So let's figure that out now. So we'll go to graph types, go to sine. You can see it's already moving pretty well, but you see something that's really odd. So you see it's making this other point here. Yeah, that's weird. So we shouldn't do that. So why is it doing that? Let's figure out why. Right now we have 10 points, and there's 11. It's really weird, right? You got 10, 11. So what's happening here is it's not the domain, it's the amount of steps. So basically, it's the amount of steps. The steps is basically the points in between it. So the amount of space in between this is actually 9. But we're saying the steps do it 10 times, but it's technically doing it an extra time to give it 11. It's a little confusing. The way I think about it and the way I process it is like the tree counting principle. So if you have 10 here, the amount of steps is actually 9 because 1, 2, 3, 4, 5, 6, 7, 8, 9. But 10 doesn't exist because we already have 10 points. So what you want to do is you actually want to link whatever number, excuse me, my throat's hurting too, so apologies for me clearing my throat. But we want to put in a number here. So I'm going to put the count as 12 and then put subtraction and then always minus 1 because the tree counting principle is always minus 1 and subtract, and that should be it. And macrom, go away. No, go away. Sorry about that. So now we have that, and we can hide this. So now we have this. So we can make this little wee sine curve. We may need more points. So what we can do is just add more points as well. So I'm going to add about, let's say 50 for now. We have a sine curve. And now we want to change the amplitude of this. So what I want to do is just put in a multiplication to have a multiply factor into here. I'll do like 2.0. And then now I can just change that. Now, another thing we can do is we can also make a whole new one of this. So we know that we need 2 curves, right? We need this top curve and this bottom curve. Why did I do that? Where is it? We'll have this. We could copy this one too. Actually, let's just copy this one. But so what we're going to do is create another construct point. And I like to type everything out. I don't like to copy and paste when I'm teaching or when I'm showing something because it gets confusing. So I'll type another construct point. Another move. We can do it this way. Again, there is a technically more efficient way by using this y coordinate to move it, but I'm actually just gonna show this because visually it makes sense. You construct the point, you make x this amount, and you move it. So visually it's more intuitive, but theoretically it's not actually the most efficient way to make this. Put in y. Graph mapper. Well, I'm so used to copying and pasting, so I almost did there. We can use the same number here. Nothing in this graph mapper, and we can actually just use the same coordinate here since we're using the same series. Now we go to sine. We may want to copy this one. Maybe a little easier to invert. Can't invert these, so we're not going to do that. Or maybe we can. Let's look at these numbers. So 0. What we can do, maybe this could work. Worth a shot. I think if we can invert it by just putting these as negative. Okay, so that flips it on this axis. But we actually want it all positive. Technically. Okay, so this would work, but we don't want to do this method. We want to use the same graph mapper here. And then, let me just delete this. I'll move this up. And I'll move this down. So you want to get relatively close. So that's pretty good. Oopsie. There we go. So now we have these two sets of points. This set of points that's going like this, and this set of points going like this. So let's make that into a curve by using interpolate curve. And then again, interpolate curve. So what we did is just a brief overview. We constructed a point, and then we moved those points in the y direction using a sine curve. that generates a certain amount, that generates the values based on the sine curve, and then use the multiply factor to change the pitch, or change the amplitude, excuse me, not pitch. I guess it could be pitch, but anyways. And then we control the amount of points using this slider, which also controls the length in theory as well. So technically 51 and then 1 should be a certain length. I'm not thinking right now. It also is 12:14 a.m. So I just wanted to make this because I found it kind of interesting. Anyways, so what we're going to do now is we go in perspective mode, and we notice these are all flat, which is not good. So if we want to replicate this exactly, we're going to take the ones, we're going to try to look at some of the images. We'll just use this one. We just want to make sure it looks something like this. So which curve does that better? I think this one should stay the bottom, and this one should stay the top, which is convenient because I made this top and bottom already. But truly, it doesn't matter. You can always switch it at the end if you don't like it. So we'll move this in the Z direction. Technically, you can also construct a point at the coordinate you want. I think you can just do that. I could be wrong. Oh, yeah, you can. Okay. Technically, we don't even need to do this, but it's intuitive as well. So this will give me the height, so we'll say 50 as well. Of course, it's 50 millimeters, so it's pretty small, but we are just working with theoretically unitless, but we have millimeters right now defaulted. And then let's just try this real quick. I just want to loft and show you guys what the surface looks like. Oops. So it looks something like this. So if I bake this real quick, it'll look like this, which is pretty cool. It's kind of what I wanted. Oopsie. Sorry, I got distracted. So this is what I want to some degree. It's pretty similar. Obviously the pitch here is a lot higher, but right now we're going to change, we have the base, so that's good. So we can get rid of that. Now we don't actually need to loft this. It's just a good visual representation though. But what we want to do is we want to draw a line in between each one of these. We actually don't even need the curves either, but they're good visual representations. So what we're going to do is take those points and then flip with those points. And now we get this. Now, this can happen. So sometimes when you do this, something like this, it'll look like this. And you're like, oh my God, that's not what I want. So the problem is that your list is reversed. So let's just say that this is the whole thing. What you would do is do a reverse list, put this into here, and then now you get this back. It's either or. It just depends. You only have to do one of them. You don't have to do reverse list for both. But in this case, they both worked out, so that's good. And now what we want to do, now they have these blocks. So I want to like extrude along a curve based on planes. So I think the best way is do a perp plane. I think this would be the best way. Make this the parameter at 0. So what this does is it just makes a perpendicular plane based on a curve at a parameter. So you have to change this to reparameterize. So it reads as 0 to 1 always. And they set that to 0. So in this case, we know that the curve is going from top to bottom, which I don't really like. So I may actually just flip this curve. The reason I don't like it is just in my brain it's not as intuitive. So it makes the planes on the bottom. Also, it's a little hard to see. So I'm going to do only one for now. So we'll list item. And it's this one. Great. Okay, cool. And we'll make sure something works. So we'll do 1.0. And then just slide down. It looks like it's working pretty well, actually. You can see the planes changing. Sweet. Okay. So we can put this back. This is just a test. Now, what we want to do is, I am thinking, okay, let me think this through. I want the distance in between this and this on an extremely non-biased way. So biased as in like I need these points kind of projected. I want to take a distance from, for example, like if I draw a line in Rhino from here to here, I would assume that's like 1 millimeter. So we know it's 1 in this case, right? Because we technically did this right here by the steps. So we know it's 1. So in this case, we can change that to 1.0 and define it. You don't have to, it's defaulted already, but we define it at 1, makes it a little easier to understand. Okay, great. So now we know it's 1. So let's actually just draw a rectangle. We can sweep these later, so that's what we're planning to do. So we do a plane, we got a rectangle. Now it asks for an X and Y size. So what I'm gonna do is you have to, if you want this to work, because rectangles are made through domains, you gotta do a construct domain. And I'm actually just gonna copy and paste this one because construct domain is a pain to type because I always spell construct wrong when I type really fast. And then you want to do negative. So it goes through both domains. So you can see in the rectangle if you look at X size, it says -1 to 1. So technically it's -1, 0, 1. So it's 2 technically. So it's 2 units as you can see. We want it to be 1 unit. So let's do that. And we want it to be square for right now. So we just need to find where the step is. In this case, it's this. Now we're going to plug this in, right? All the way here. And we plug these in. Voila. We got it to work. So we got 1 here and 1 unit here. I got 1 to 1. So these are defaulted to that. So theoretically it could have worked as well. But you just want to define it because at the end, if you want to change this to be parametric, then when you like change this value, it'll follow along with it. In this case, the defaulted did work, but you don't want to rely on that. It's not good to do that. Great, so that works. So let's just do a sweep now. The railing would be this list item. Now we have this. Not exactly what I'm thinking. Because it seems pretty wavy here. Oh, well, this is wavy at least. We have a little wave going on. But it does look straight in some. I don't know if that's the angle of the picture. No, it's definitely wavy. It's not straight. As you can see, it's wavy here. Interesting. So they do have some, like, it's not a straight wave. That's why I thought this looked a little funny. Interesting. So we may need to do is have different control curves. We may have to have 3 separate control curves. Right now we only have 2, so it'll always be a straight line. But we need it to be a curve here, profile-wise. So what we need to do is find the top one. You probably want to make one for the middle. So they looks like they could have, in theory, they have this curve, the base, the top. And it looks like, because these stones are curved in some way, some of them are, but some of them also look straight. I don't know, it's also a little hard to tell in this image. I wonder if I have any more images. No, it's definitely curved. No, that is definitely curved. Let me review the geometry a bit more. So they have this. So it looks like there is some mediation curve. As you can see, there is a middle curve that does define some of this here. It's another kind of sine curve that really defines it. So we could just do this. One thing we can do, let's try this. So we have 50. We could try to divide this by 2 and then also plug it in. What I like to do is do a merge and control that. Okay, and try that out. No, it's not going to work here. Okay, so I only did one, but maybe I need to graft my results here. Perfect, perfect, perfect. Okay. So now we have these two, and when it draws a line, it draws it all completely wrong. So I already knew that was going to happen. So now we have these three. We just need to reorder them to make sure they are in the right order in this case. So let's see. So these are all the points here. What I need to do, let's make, I'm gonna try is flattening this first and then merge this one first and then this one first. Let's see what this does. It's probably gonna freak out. Yeah, it's gonna do something like that. I kind of expected that. Yeah, when you add a third parameter, it always gets funky. As you can see, it's also making the curve twice, or one curve. It's just looping around. Interesting. So I think the way I'm gonna do this, I'd probably have to make a third one. This was just like a quick test. Third one would be easier. So I'm just going to, in this case, just use 50. This will be the top one. Oh, actually, I can still use that stuff. So I will just move this up. Move this here. Move this here. Gotta do a little housekeeping chores here. And then do a list item. Nope, not list item. I need to do another move. So in this case, I'm going to, well, this is set to Z. So I need this to be here. Plug that in. And then, oopsie, plug this into here. Plug this into here. Now we have these two separate, so we have, oh, we don't need to flatten this anymore. 1, 2, and 3. So what I'm thinking is this can also have its own graph mapper. I can use the same range and use the same graph mapper. So I'll just copy and paste this one into here. Okay. Okay. Let's see. We have this. Okay. Now we have those three, 1, 2, and 3. So the way to test this, we know that this one works. And this should work. And I'm also gonna disable all this. So you can actually disable so it doesn't run the commands. So we know those work. We can do this. We can do a merge from the top down. All we have to do is now graft all these. Do a panel, and it should be a set of 3 points. Yes, sweet. So we can actually just do a polyline here. See what that gives us. Nice, okay. So we probably need to play with this graph mapper a little bit so it looks a little weirder. Probably need to play with this graph mapper a tiny bit. And then also this multiplication value should be slightly higher based on, well, 15 seems a bit excessive, but let's see, we have 3.5. Yeah, that's a bit excessive. Let's just do a 4.0. So this will be the middle one. Has to be slightly different from the other ones. So that one will go this way. Actually, maybe multiply this negative because it is going inwards like that. This is division. I may just have this as a slider. Okay. So that should work. Something like that. Right now it's polyline, so it's not going to be smooth like the other ones. what we need to do now is take this curve, I want to say, and just, I want to try to take this graph mapper a little bit and actually flip it the other way. Because it looks like it's better that way. Let's try changing this negative. That looks better. And then the height of this should definitely be different. As you see, it's now looking a little better. What we're going to do instead of a polyline, we are going to use a interpolate curve. Now that look a lot smoother. Oh, it's still making this line. I was wondering, I was like, what's going on? That looks smoother, but also a little funky. May want to tone that down a bit. And also tone that. May need to just change these pitches too in here. What's my multiplier in here? Yeah, we'll just change it to something pretty extreme. Something like that, for example. And then it needs to be a tiny bit wider. Oh, something like that. Yeah, that looks a lot better, actually. That looks really good. Great. Awesome. Okay. Wow, I forgot to save. So, here, let me save this real quick off screen. Sorry, I have some other projects I shouldn't show on screen. They have some NDA stuff. So let me save this in kinetic architecture. We'll just call it stone curve facade for now. Great. Okay. So now we have this curve. We want to take the flip curve here and then just plug this back in. We can start them all at once. If I didn't have this list item, I probably wouldn't do this. But since we do, we can just restart everything. Oh my God. Maybe I shouldn't have done that. Oh my God. Okay. Let's not do that again. I'm lucky I didn't crash my computer or anything or weird. So it looks like when I did this, it made all of them grafted. Should have checked that, honestly. That was stupid because when you make 3 curves here, or you make a curve out of this, it'll treat this as one. So this will now be one geometry under this one branch. So it'll look something like this. So this should actually be flattened. And now we should be able to execute the commands. That looks a lot better, honestly. So now we'll try it with everything. Well, that didn't work. That's ironic. So that worked with 1. It seemed to work grafted better. If I do a perpendicular frame, this sweep always screws things up. So I'm going to just try with a perpendicular frame first. Yeah, that looks right. Okay. Okay. I'm confused why sweeping these wouldn't work. They're both like curve, rectangle. The only thing I can think of is the curve. I don't want to have to graft it. Well, if I have to, then I will, but no, that's right. That's weird. Maybe I do have to graft it. It's strange. I'll graft it from here. I don't want to graft it from there. So we'll do that. Use the curve. We'll try that out. Now it's a little hard to see because it's just a crap ton of red. But we will change this material to be a different color. Just pick something gray. I mean, it's a rock. So we'll just do like this. Oh my god. So then what we can do is highlight everything. Use the blindfold dude. Let's see what that looks like. It looks pretty good. But I don't know why it's pink still. Probably could be my emissions. This is what it should glow, technically. So we'll change that to silver. Pick a gray, a little darker. Emissions, see, specular. Okay. Okay, so you see there's this error here with the curves. So one thing I notice is this curve is making it correctly. But as you can see, it's doing this. So actually, this should be half. This should be half here, and this should be half here. So I actually need to do this division and take all those values. Well, first I'm going to nullify this. Take all of those values and divide them by 2. So what I'm going to do is a panel here. Okay. And then this. And then divided by 2. Oops. There we go. Now when we turn this rectangle on, yeah, you can see there's not going to be a seam there. Or it'll be a seam, but it'll be a lot cleaner. It's not going to, we do some weird overlapping. Yep, it's great. It's not going to do weird overlaps. So they probably have their panels slightly bigger here. So I probably need to change this Y to be something else. So I'll just start with 5 for right now. Okay, wrong value. So swap real quick. Okay, maybe not 5. Sweep can stop. I just need the rectangles to show me. Let's try that. Let's check our image. Okay, so they have it wider too. I mean, they have it wider as well. That's why it looks a little funky. So this step actually should be bigger. So what I'm going to do is change this value to be max range of like 50. And then expand it a little bit. Well, maybe not that much. We'll do like 5 first. Of course, this is all proportional. I'm just trying to make it look better. And then move this up taller. So right now I'm just tweaking what it should look like. Okay. Perfect. Bake this. Turn this off. Close out. Now, one thing I forgot to do in here, and there is some, oh no, it's not overlap. It's actually pretty good. In real life, you're not going to have it touch like this. If you fabricate this, you will have it like, I don't know if it shows it well in here. Well, I actually show no joints. Damn, it's actually pretty good. usually there will be a joint. Oh, there is a joint, but it's very well hidden. I did a good job on that. There is a joint in between this. So the joint will be whatever distance you want, but you need to take whatever half distance you have here and then just subtract from there. So in this case, it will show a slight gap. What you would just do is subtract this number and then plug it back into here. I'm not going to show that because this is just for visual sake. The other thing I forgot to do is, where is it? This looks pretty good. One thing I forgot to do as well in Grasshopper is cap it. So use a cap. And then, now some people would, now you can see that these curves are a little exaggerated too. You can see that it's not perfectly flat either. So normally I would do that in Rhino. I wouldn't waste my time doing that in Grasshopper because it's just a waste of time. So I would just draw a plane at, we'll do by center, 0. Okay, now I've got a big plane. Now normally I would extend these curves in Grasshopper. So in Grasshopper, maybe we can do that actually. You can take those curves and extend them. Start end, we'll just do 10. And this should be natural. No, natural or smooth. Yep. And we'll just plug this in here. Perfect. And now we will bake this. Well, not this one. We'll bake this. Perfect. And now we did it by 10. So all we need to do now is, what was that total height? Total height is 90. So I just need to move it into Z 90. So move vertical 90. Oh, oops, I already messed up. Vertical 90. Oh, I shouldn't. My bad. I shouldn't copy. Do 90. And then do a Boolean split. Now it comes in grouped. I group it always. So you have to go into right view. Delete all these and then do another Boolean split. Delete that. And now you got flat edges. And now you have this. Perfect. Well, it's not perfect, but it is close to what will be represented as this. Yeah, it's pretty close actually. They have it actually expand out here like mine does. Theirs is a bit bigger. They have a bit wider. Mine are a lot more cubic. So they definitely did. They also have structure in there. So I didn't do any of the structure. I just made the general volume and the principle behind it. So yeah, that's pretty much it for this tutorial. I shouldn't drag on too long. It's already been, what was it, 38 minutes? So yeah, guys, that's pretty much it. I can't really promise any more videos. I'm super busy with school and super busy with work as well. So I'm doing both at the same time. And it's a bit rough, but also rewarding at the same time. But yeah, guys, hope you guys enjoy this. Thank you guys for watching. Hope you guys have a great day. And watch out for any more tutorials. I may do some more. I can't guarantee it. But anything I come across through Instagram or Pinterest or anything, and if I have an idea on doing it and it's very quick, then I will do it. All right, take care.